Hello, welcome to Chapter 4, homework questions 39 through 44. Question 39, find the missing side length for each triangle. Use the tangent button on your calculator to help. So on part A, we have 8 degrees. So we will say we're looking for the ratio of 8 degrees. So that's tangent of 8 degrees is equal to the change of y, which in this case is t, over the change of x is 82. So that's your slope ratio. Go ahead and plug in tangent of 8 degrees in your calculator, and you'll get approximately 0.141, and so that's approximately. Then we can multiply both sides by 82, and so when you take that times 82, you get an approximation of 11.56. So t is approximately 11.56. Now, if you use the exact value in the calculator, you'll get t is approximately 11.52. So you might get a couple variances depending on how you are rounding your tangent of 8 degrees. On part B, on this one we have tangent of 75 degrees, and delta y this time is 12, and delta x would be p, so your slope ratio. So tangent of 75 degrees is approximately 3.732, and so that's approximately, and then we'll multiply both sides by p. So that'll be 3.732p is approximately equal to 12. And then we can divide by 3.732. And so we'll get p is approximately divided by 3.732, 3.215. On part C, we have 68 degrees, so we'll use tangent of 68 degrees. Now remember, the side opposite the angle is our delta y, so that would be b, and then delta x would be 60. So if you think about using transformations to create your slope triangle and make the 68 down here, then that would be b, and that's why your delta y is b. So we have tangent of 68 degrees, which is approximately 2.475. And then we can multiply both sides by 60. So 2.475 times 60 is approximately 148.5. So B is approximately 148.5. And once again, if you are using the exact value of tangent of 68 degrees in your calculator, you might get even a closer answer to the actual value. Question 40. Use the relationship in the diagram below to write an equation and solve for x. So since we have a right triangle on A, we can use Pythagorean theorem. X squared plus 18 squared is equal to 30 squared. So x squared plus 18 squared is 324. And then 30 squared is 900. Subtract 324 from 900, and you get 576. Oops. And then on that one, you can take the square root of 576. And you get an x value of exactly 24. On part B, you're given all the angles around an entire circle, so that's 360 degrees. So we can use the sum of all of these to be equal to 360. So I'm just adding them all up, 360 degrees. combine your like terms. So it'll be 6x and 8x. And then 20 and 20 is 40. Subtract 40 degrees from 360. And that's 320 divided by 8. X is equal to 40. So x is equal to 40 degrees. Part C, you're given two triangles. This angle and this angle are congruent. And then 20 degrees is congruent to 20 degrees. So we know that these triangles are similar by angle-angle similarity. And so then their side lengths are in proportion. So this length between the two angles of 5 matches up with the 3. So we'll say the ratio of 5 over 3 is equal to this length that forms the 20 degree angle. Matches up with this one, so that'd be 12 over x. And then we can solve for x and get x is equal to 36 divided by 5, and that's 7.2. Question 41, what is the relationship of the triangles below? Justify your conclusion using rigid transformations. So we can see that this side length matches up with this one. This one is congruent as well. So all the sides are congruent, so we know that the triangles are congruent. And to justify your conclusion using rigid transformations, we could, it appears, maybe reflect across some vertical line. Maybe about right there, and then once that reflects, then you will be able to shift it down. So probably a reflection and then a translation. And that's one way to do it. There's other ways that you could do it as well. Question 42. Alexis, Bart, Chuck, and Daria all called into a radio show to get free tickets to a concert. List all the possible orders in which their calls could have been received. Alright, I went ahead and listed all of the possible orders in which their calls could have been received, and the way I set it up was, for example, I said, Alexa, if she has the first call, then she can call first, then Bart, then Chuck, then Daria. And then I just switched these two around. So I kept Alexis and Bart first, and then I switched Daria and Chuck around. And then I just kind of repeated that process. So still Alexis is first, but then I went ahead and put Chuck second, and then switched Bart and Daria around for these two. And then put Daria second, and then Bart and Chuck, switch those around. And since I could do that 6 different times for Alexis being first, then I could also do it 6 different times for Bart, Chuck, and Daria when she was first. So that came up with 24 possible ways that they could, that their calls could have been received. Question 43. When she was younger, Mary had to look up at a 60-degree angle to see her father's eyes whenever she was standing 15 inches away. How high above the flat ground were her father's eyes if Mary's eyes were 32 inches above the ground? So I went ahead and drew the picture so I could get an idea as to what it was we were looking at. She's looking up at a 68-degree angle to her father's eyes. She is standing 15 inches away. And then she's 32 inches above the ground herself, and we're trying to figure out how high above the flat ground that her father's eyes are from the ground. So we're looking for that total distance. Now we already know, based on Mary, that this is 32 inches. So really I'm looking for this length right here. So we have a right triangle, we have one side length and an angle, so we can do tangent of 68 degrees is equal to, we'll just call this x. Well, since it's the delta y, we'll call it y. So y divided by 15. Tangent of 68 is approximately 2.475. So that's approximately equal to y over 15. We can multiply both sides by 15. And we get a y value that is approximately 37.125. Now that's just this value right here, 37.125. So then we have to add the 32 to that, and we get a total value of 69.125 from the floor to the father's eyes. So once again, make sure you answer the question. 69.125, that's inches from father's eyes to ground. Question 44. This problem is a checkpoint for finding area and perimeters of complex shapes. It will be referred to as checkpoint 4. For each figure below, find the area and perimeter. So in the first one, we can find the perimeter by adding up all the sides, or in this case, we can take 16 times 2 plus 10 times 2. So the perimeter is 32 plus 20, or 52 centimeters. Make sure you label. For the area on this one, this is a parallelogram, so we can take the base times the height, which is 9. So the area is equal to 144 centimeters squared. For B, the trapezoid, the perimeter is add up all the sides. We'll start with the 21 plus the 44.67 plus 25 plus 24. And so we can add all that up and get a perimeter of 114.67. And that is in meters. Let me fix my 7. Alright. And now the area, it's 1/2 times the height is 20, and then base 1 plus base 2. So that's 25 plus your 44.67. So half of 20 is 10 times 69.67 for an area of 696.7 meters squared. Part C, see if we have all the side lengths that we need for the perimeter. So this will be 2 plus, we don't have that one yet, so we'll have to figure that one out. 7 plus 9 plus, skip a couple of them there until we can figure it out, plus 5 plus 3 plus 2 plus 12. Now we got to go back and figure out a couple of them. This one over here would be 3 because it matches up with that one, so we can add that one in. If this distance right here is 7, and then this is 2 and this is 2, so that's good. So this whole distance here, right here, from here to here, needs to also be 7. Well, if this is 5, then this can be 2. And then the last side length is over here. And the full length is 12, and the bottom length is 9. So that means that has 3 left to give to make the full length of 12. And when we add up all those numbers, we get a perimeter of 48 centimeters. Alright, now to look at the area. Let me get rid of some of these right here so we can mark it off into different ones. So we can take the area of this one, and then that, and that. So it looks like we have 4 different areas. 1, 2, 3, and 4 that we'll be looking at. So the first one, we said this had a length of 3. So 2 times 3 is 6. So we have an area of 6 plus square rectangle number 3 is 2 by 3. So we know that's 6 also. Same thing was down here. This was a 2 by 3, so that's a 6. So we have 3 6s. And then what's left here? Well, this entire distance is 7 plus 2 is 9. And then this entire distance here, well, we have 9, but we know this is 3. So that's going to represent, wait, hold on. So that whole thing is 9, and then we take that 3 off, so that means this would be 6, which would also make sense on top because this one's 3 and this one's 3. So it gives us 6. 6 times 9 is 54. So that gives an area of 72 centimeters squared. Alright, and on the last one here, we have the perimeter. We're just going to work our way around again. That's 10 plus 23 plus 10 plus 4 plus 2 plus 3 plus 2 plus 4. So we had all the values, we just need to add them up, and that will give us a perimeter of 58 feet. Now for the area, let's get rid of all those lines. How can we break this one up? We're missing a little notch out of a isosceles trapezoid. So what if we find the entire trapezoid as if that was filled in, and then we'll just subtract the area of that, which is 6. So let's find the area of the trapezoid and then subtract 6 from it. So the area of the trapezoid excuse me, is 1/2 times 8, which is the height, times the base. The sum of the base is 23 plus 11. Remember, it's 11 because you have 4 plus your 3 plus your 4. So that entire distance is 11. So that means we have an area. Half of 8 is 4. 23 plus 11 is 34. So the area is 136. But remember, we have to subtract that little notch in the trapezoid of 6. So therefore, we have an area of 130 feet squared. So sometimes, like on C, we had to add in the little extra pieces, and then on D, since it was just missing one piece, we subtracted that out.